Meet Ludwig Boltzmann, the man who bet everything on the existence of atoms when the scientific elite still thought they were just a handy fiction. In The Architect of Atomic Reality, we trace the brilliant, often misunderstood journey of the father of statistical mechanics. By formulating his iconic entropy equation, S equals K log W, Boltzmann gave us the arrow of time, proving that the universe's drift toward disorder isn't just a hunch, it's math. From his revolutionary H-theorem to the probability of reality itself, this presentation explores how one man decoded the chaotic dance of molecules to explain why we can't unspill milk or reverse the clock. It's a profound look at the physicist who dared to quantify the invisible. Picture a world of clockwork, the Newtonian universe. It is a predictable, reversible machine where every action is a direct result of the last. But Ludwig Boltzmann saw a hidden reality that changed everything. In the Boltzmann universe, the neat gears of old are replaced by a chaotic, probabilistic swarm of atoms. While Newton's laws looked backward and forward with ease, Boltzmann introduced irreversibility, proving that the universe has a preferred direction. He mapped the mathematical rules of this invisible dance, but this vision came at a high price. By looking where others refused to see, he bridged the gap between microscopic chaos and macroscopic order, forever shattering the illusion of a deterministic world. Boltzmann's life was an oscillation of brilliance and despair, a trajectory mirrored by his restless moves across Europe. From earning a doctorate at 22 to his most productive years in Graz, his path initially soared. However, the wave eventually dipped. His journey through Munich, Leipzig, and back to Vienna was increasingly defined by professional isolation and bitter intellectual clashes with rivals like Ernst Mach. This wasn't just academic fatigue. It was the outward manifestation of a mind struggling with undocumented bipolar disorder. Even as he defined the laws of thermodynamic equilibrium for the universe, he found it impossible to achieve for himself, a man in constant motion, caught in a cycle of peaks and valleys that defined both his genius and his tragedy. In the 19th century, thermodynamics was a science of the visible, measuring the raw power of steam and heat while ignoring the microscopic engine beneath. To the scientific establishment, atoms were nothing more than convenient mathematical fictions or philosophical fluff. They believed only in energy and continuous matter. This was Boltzmann's battlefield. His monumental challenge was to prove that the heat we feel is actually the result of billions of invisible particles colliding in a frantic dance. He dared to argue that the macroscopic laws of the world were rooted in a microscopic reality that others refused to acknowledge. It was a lonely crusade to turn fictions into the undeniable building blocks of our universe. Enter the H-theorem, Boltzmann's mathematical proof for why time only moves forward. Look at these particles. They begin in a rare, highly ordered state of low entropy. But as they collide and scatter, they naturally drift toward equilibrium. Why? Because disorder isn't just inevitable, it is statistically overwhelming. Boltzmann's theorem, dH over dt is less than or equal to 0, reveals that the arrow of time isn't driven by a mysterious force, but by simple probability. There are simply vastly more ways for a system to be messy than to be neat. From a shattered glass to the expansion of the cosmos, Boltzmann proved that our reality is a one-way street dictated by the relentless logic of the most probable outcome. This is the heart of the mystery, S equals K log W. It is perhaps the most profound bridge ever built in physics. In this slide, we deconstruct the formula that translates the microscopic into the macroscopic. S is entropy, the disorder we see, while W is the Wahrscheinlichkeit, the staggering number of ways atoms can be arranged. Linking them is K, the Boltzmann constant, acting as a translator between microscopic energy and the temperature we feel. The logarithm ensures that as probabilities multiply, entropy simply adds up. This equation proves that entropy isn't some mystical force of decay, it is a mathematical certainty. In a universe of trillions of particles, disorder is quite literally the most probable outcome. Imagine the universe not as a rigid machine, but as a cosmic casino where the odds are forever stacked in favor of chaos. This slide captures Boltzmann's most radical legacy, statistics as physical law. He took the second law of thermodynamics, once seen as an absolute, mechanical certainty, and transformed it into a masterpiece of overwhelming probability. As the dice fall, they represent a fundamental truth: the universe doesn't break its laws, it simply plays the odds. This revolutionary shift proved that the inevitability of entropy is actually a statistical landslide. In Boltzmann's world, we aren't governed by unyielding gears, but by a mathematical reality where the most likely outcome becomes our destiny. Intellectual giants clashed in a battle for the soul of physics. Boltzmann stood firm against the titans of his era, defending the reality of the invisible. Ernst Mach dismissed atoms as mere metaphysics, while Wilhelm Ostwald branded matter an illusion, seeing only energy. Even peers like Loschmidt and Zermelo challenged that arrow of time, arguing for reversibility and recurrence. To each, Boltzmann offered a brilliant retort. Atoms were essential to explain the heat we feel, and while the impossible might be mathematically plausible over infinite eons, the overwhelming odds of the universe dictate our daily reality. This table captures a man under siege, fighting not just for his theories, but for the very existence of the atomic world against a skeptical establishment. Ludwig Boltzmann often felt like the last sentry at the gates of a truth no one else wanted to hear. This slide reveals the deep emotional exhaustion of a man who spent decades as the lone defender of atomism against a hostile scientific establishment. Surrounded by the very particles he spent his life proving, his own words resonate with a haunting vulnerability: "I am conscious of being only an individual struggling weakly against the stream of time." This wasn't just a professional battle. It was a psychological one. As the establishment's resistance continued, the sheer weight of being the architect of a new reality began to shatter his fragile mental health, transforming a brilliant career into a solitary struggle for survival. Beyond the complex equations and atomic theories, Ludwig Boltzmann was a man of immense depth and passion. As an accomplished musician, he found solace in the works of Beethoven, playing with the same intensity he brought to science. His romantic spirit led him to challenge the era's rigid social norms, fighting for his wife Henriette's right to study physics when doors were strictly closed to women. A visionary ahead of his time, he foresaw the potential of fluid dynamics and even acted as an early investor in aviation. Finally, we see the charismatic lecturer, a self-deprecating teacher whose crystal-clear insights drew massive, enthusiastic crowds. Boltzmann was a multifaceted human whose heart was as vast as the universe he decoded. Now we enter the darkest chapter of Boltzmann's life, the descent into chaos. The brilliance that illuminated the atomic world was being extinguished by a triple threat of collapse. Physically, his body betrayed him with agonizing asthma, chronic headaches, and failing eyesight that forced him to hire assistants just to read. Mentally, he was a prisoner to undiagnosed bipolar disorder, trapped in a relentless cycle of manic productivity followed by paralyzing, crushing depression. Finally, the professional isolation reached a breaking point. After decades of intellectual combat with hostile peers like Mach and Ostwald, exhaustion and paranoia set in. The man who quantified the universe's entropy was ultimately consumed by his own, as his internal world spiraled toward a tragic, final disorder. The journey reaches its heartbreaking conclusion in the quiet coastal town of Duino. On September 5, 1906, the man who decoded the laws of universal disorder could no longer find order within himself. Seeking escape from a crushing, lifelong depression, Ludwig Boltzmann took his own life at age 62. The ultimate tragedy lies in the timing. Boltzmann died under the heavy shadow of perceived failure, believing his revolutionary atomic theories had been cast aside by the world. He vanished into the very chaos he spent his life defining, tragically unaware that the scientific community was on the brink of finally proving him right. It is a somber end for a visionary whose vindication arrived just a moment too late for him to witness it. The tragedy of Duino was not the end of the story, but the beginning of a revolution. In 1905, Albert Einstein used Boltzmann's statistical mechanics to explain the jittering dance of Brownian motion, providing the theoretical breakthrough the world needed. By 1909, Jean Perrin's meticulous experiments provided the physical proof, calculating Avogadro's number and silencing the skeptics forever. The atom was no longer a fiction, it was a fact. Boltzmann was entirely right. Almost immediately after his death, the scientific establishment that once fought him pivoted toward the reality he had spent his life defending. Though he wasn't there to see it, the architecture of the atomic world was finally confirmed, turning his lonely crusade into the foundation of modern physics. Though his life ended in shadow, Boltzmann's legacy shines as a cornerstone of modern science. Here, we see his final resting place in Vienna's central cemetery, grave of honor, that stands as a testament to his ultimate victory. Carved forever into the stone is his masterwork, S equals K log W. This simple expression did more than explain heat, it laid the groundwork for quantum mechanics, information theory, and our understanding of the very birth of the cosmos. Boltzmann transformed physics from a study of the certain to a study of the probable, teaching us that even in a universe trending toward disorder, there is a profound, mathematical beauty. The architect of atomic reality finally found his place among the immortals. In this final look at the architect of atomic reality, we witness a legacy that has fundamentally refined modern science. Boltzmann's insights became the bedrock for three revolutionary fields: quantum mechanics, where his statistics guided Planck and Einstein; information theory, which adapted his entropy to the digital age; and cosmology, providing the tools to understand the Big Bang itself. He was the mind that dared to define the rules of chaos, transforming our view of the universe from a rigid machine into a vibrant, probabilistic dance. Ludwig Boltzmann didn't just study atoms, he secured our understanding of the atomic universe, proving that within the vast complexity of the cosmos, the laws of probability remain the ultimate truth.